Okay, right, and last question, question 19. Well done if you stuck with it right the way through to this. And this is on parametric equations. Right, part A here is something that I haven't actually taught you how to do yet, but it's dead easy, this. So, when we get parametric equations, if I've got x in terms of t and y in terms of t, what I can do is I can differentiate x with respect to t. So usually we differentiate y with respect to x, that's what dy by dx is, and that's when we have something that's like y equals a function of x, and y equals 2x squared plus 7x minus 4 or whatever. So what I can do here is I can differentiate both of these things, and if you think about it, if I get dx by dt and I also get dy by dt, then I've got a dx and a dy there, just not in the right place. So if I get this thing, if I can figure out what that is, I can flip it upside down and multiply it by that. Because if I times in two fractions together, the dy and the dy, the dt and the dt there go, and I end up with dy by dx. So what I'm going to do is I'm going to differentiate. I'm going to get dx by dt, and that is going to give me 3. I'm going to get dy by dt. Now this one's a little bit trickier because I'm going to write that as 5 minus 6t to the minus 1. So the 5 will disappear, times by the power, which will turn that into plus 6, decrease the power by 1. So I'll get 6t to the minus 2, which is 6 over t squared, and it's important that you write it like that. So if I want to get dy by dx, I need to flip this one upside down. If dx by dt is 3, dt by dx is 1 over 3. So if I do that multiplied by that, it'll give me dy by dx. Which end up giving me 6 divided by 3 will be 2, so it'll be 2 over t squared. Okay. Right. The point P lies on C where t equals a half. Find the equation of the tangent to C at the point P and give your answer. That basically is y equals mx plus c. Okay, so now that we know a value for t, we can figure out quite a lot here. We can figure out what m is because that's your gradient function there. So m must be 2 over half squared at the point C. That gives me 8. And what I can also do is if I sub t equals a half into these original two parametric equations, it'll give me the x and y coordinate at that point. So x will equal 3 times a half minus 4, and that ends up giving you, I think it's 5 over 2. Let's just do that on the calculator. 3, where are we, times half minus 4, that gives you minus 5 over 2. Y equals 5 minus 6 over a half. 6 divided by half is 12. 5 minus 12 is minus 7. So that tells me that the coordinate for C is minus 5 over 2 minus 7. And I've got my gradients up there, so I can now use y minus y1 equals x minus x1. So y minus minus 7 equals n, which is 8, brackets x minus minus 5 over 2. Okay, so that's going to be y plus 7 equals 8x. And that's going to turn into a positive because I've got minus minus 5. 8 times 5 is 40 divided by 2. That'll be plus 20. So we'll end up with y equals 8x plus 13. And that's the format that was asking for up there before, wasn't it? Y equals something x plus something. And we've got that there. Right, and part C, show that the Cartesian equation for C can be written like that, where x can't be minus 4. Why can x not be minus 4? Because if you make x minus 4, it makes 0 on the bottom of this fraction. So remember that what this means, Cartesian equation, get these things to basically sub one of them into the other, or set them equal to each other, or basically just put them together somehow. Now if you look at these two, that's the kind of nastier one out of them there, isn't it? And the fact that this says that it wants it in terms of y equals, it implies, I think, that you want to leave this sort of alone, rearrange this one and put it into there. So I'm going to rearrange this to get t, so that's going to be x plus 4 equals 3t, x plus 4 over 3 equals t, and then I'm going to sub that into there. So I'm going to get y equals 5 minus 6 over x plus 4 over 3. Right, and then it's just tidying this up. If I'm doing 6 divided by this fraction, that's the same as doing 6 multiplied by that fraction the other way around, which would be 6 times 3 over x plus 4, so that'll be 18 over x plus 4. Straight away there, I'm thinking this is probably the right tracks because I've got x plus 4 on the bottom of that fraction there. Okay. The problem that I've got at the minute is the 5. So to get the 5 to be able to link into all this, to be able to kind of express all that right hand side as a single fraction, I need to multiply the 5 by x plus 4 over x plus 4, which means that I'll have the same denominator as the 18. And then I can write that as one single fraction like that. Okay, so what I've done there is I've multiplied the 5 by x plus 4 over x plus 4. So that'll give me y equals 5x plus 20 minus 18 over x plus 4. Let's simplify that. It's 5x plus 2 over x plus 4, and that's the end of it.